Have you ever just wondered how an idea, something in your head, turns into an actual app on your phone or computer? Well, today we're going to peel back the layers on that whole process. We're going to follow the path from a simple human thought all the way to a set of instructions a computer can actually follow, and we'll be using the C programming language to guide us. Let's dive in.
Okay, so here's the biggest hurdle right off the bat. You've got this great idea, right? But the computer, it's just a machine. It doesn't get things like we do. It has no idea what kinda or sort of means. It needs incredibly precise, literal, step-by-step instructions for every single thing. So the real puzzle is, how do we translate our creative and, let's be honest, sometimes messy human thinking into the pure, cold logic of a computer?
So, how do we solve that? Simple. You make a plan. A really, really good plan. Seriously, before you type a single line of code, you have to have a blueprint. You need to break your big goal down into a series of small, logical steps. And in the programming world, that blueprint has a special name.
And that name is an algorithm. But hey, don't let that word scare you off. An algorithm is just a recipe. That's all it is. It's a clear list of instructions that, if you follow them exactly, will always give you the right result. The key things to remember are precise and finite. Every single step has to be crystal clear, and the whole process has to eventually come to an end.
Let's make this real. Imagine we want to convert Celsius to Fahrenheit. What's the recipe? It's super simple, right? You grab the Celsius temperature. You do one quick calculation. You show the answer, and you're done. See? Each step is tiny, totally clear, and just flows right into the next one. This is exactly what we mean by breaking a problem down.
But what if you're a visual person? How do you actually see the plan? That's where a flowchart comes in. Think of it like a map for your recipe. It's awesome because you can see the whole journey at a glance. The ovals are your start and finish lines, the parallelograms are for getting info in or spitting results out, and the rectangles? Those are the heavy lifters where the actual calculations happen. And of course, the arrows just show you which way to go.
All right, so we've got our blueprint, we've got our map, the logic is solid. Now for the big step, we have to translate this whole plan into a language the computer can actually understand. And for this explainer, we're going to learn to speak C.
Yeah, we're talking about C. It's one of the heavyweights, one of the most influential languages ever. It's been around since 1972, and it's famous for being super powerful and portable, which just means you can write code on one machine and it'll probably run on a totally different one without much fuss. So many other languages and even operating systems, they all stand on the shoulders of C.
Now, just like English has words and punctuation, C is made up of little building blocks. The smallest possible pieces are called tokens. Think of them as the individual words and symbols of the C language. You've got things like keywords, the core vocabulary, and identifiers, which are just names we make up for stuff, and so on.
Let's zoom in on keywords for a sec. These are special. They're the built-in, reserved words that C already knows. You can't mess with them. Their meanings are locked in. Words like int when you're talking about a whole number, or float for a number with decimals, or if for making a choice, these are the absolute bedrock of the language.
Okay, so we've got the vocabulary down, but a program that can only talk isn't very useful, is it? It needs to remember things. It needs a place to stash information, like that Celsius temperature we talked about earlier, so it can work with it.
And that, my friends, is where variables come in. The idea is so simple, but so powerful. A variable is basically just a labeled box in the computer's memory. You give the box a name like Celsius_temp, and then you can put a value inside it. That's how our program keeps track of everything. Now here's a key rule. You can't just throw any old thing into these boxes. You have to tell the computer what kind of stuff you're going to store. Need a whole number? You tell it, hey, this is an int. Got a number with decimals? That's a float. Just a single letter? That's a char. Being specific like this helps the computer manage its memory and keep things running smoothly.
Okay, great. We've got our storage boxes, our variables, and we know what kind of data goes in them. But so what? How do we actually do anything with that data? How do we make calculations or change what's in the boxes?
That's where operators come into play. These are the action words, the verbs of the C language. You know most of these already, like the plus sign for adding. The asterisk, by the way, is for multiplication. But here's the one you really got to watch, the single equal sign. In programming, this doesn't mean is equal to. It's the assignment operator. It means take whatever's on the right and stick it into the box on the left. Huge difference. And that's it. We have all the pieces on the board now. We've got our logical plan, the algorithm,
And we have the basic C toolkit, variables for storing stuff and operators for doing stuff. So, are you ready? Let's see what it looks like when we put it all together. Boom, here's the big reveal. On the left, you see our simple flowchart, our plan. And on the right, that's the real C code. Just look at how one translates directly to the other. Define ABC sum becomes int A, B, C sum. We're literally just making our little integer boxes. The math part, sum equals A plus B plus C, looks exactly the same. And print sum, that just turns into printf, which is C's command to show something on the screen. It's a perfect one-to-one translation from our plan into code. So, what's the big takeaway here? When you really break it down, programming isn't some kind of dark magic. It's really just structured problem solving. It's a two-step dance. First, you think logically and come up with a clear step-by-step plan. And second, you translate that plan, piece by piece, into the very specific grammar of a programming language. It's all about logic and translation.
So we've seen the whole journey, from a simple thought all the way to a program the computer can actually run. And this fundamental process, it's the same whether you're building a tiny calculator or a massive video game. It all starts here. Which brings me to a final question for you. Now that you see how it works, now that you understand the path from an idea to an instruction,